today we'll be discussing about the topic that is composition of functions. It is nothing but combination of functions. So let us begin with the definition. Consider the two functions, let it be f and g, and f is given from a to b and g is given from the set b to c. Then the composition of a function is denoted by g of f. This hollow circle, what you can see here, this is not an alphabetic O or a number system 0. This is an hollow circle and that is read as of. Okay, that is G of F. That is nothing but G composed with F. And this is defined as the function G from A to C and is given by G of f, that is equal to G of f of x, and that is equal to G of f of x, and x is the value that comes from the set A, and G of f is a value that comes from the set C. Okay, this is about the definition of the composition of function. Let us solve few problems for the better understanding. Example 15. So here the function is given, two functions are given, f and g, and it is defined as f of 2 is equal to 3 and f of 3 is equal to 4 and f of 4 and f of 5 is equal to 5 and g of 3 and g of 4 is equal to 7 and g of 5 and g of 9 is equal to 11, and you need to find g of f. Okay, let us begin with the solution. So this is what they have given in equation, and here you need to find g of f. And I have already said that whatever the x value you consider here, that will be the elements that is considered in a set A. Therefore here g of f of the element in A, what are the elements that is consisting in A? That is f from 2, 3, 4, 5 to 3, 4, 5, 9. Right? So here the elements in a set A, that is nothing but that is 2, 3, 4 and 5. Okay, that is G of f of 2. Consider the first element in a set A. Okay, this can be written as of f of 2. What is f of 2? That is g of 3. What is g of 3? It is given as 7. Right? Therefore, g of f of 2 is equal to 7. And as similar to this, you can go for the second element here, that is g of f of 3. That is g of f of 3. What is f of 3? Here we'll always solve this one first, then we shall go for g, function g. Okay, so what is f of 3 here? That is 4. What is g of 4? That is nothing but 7. G of f of 3 is 7. Similarly, g of f of 4, that is g of f of 4, that is equal to, what is f of 4? This one first. What is f of 4? That is nothing but 5, which is already given. Therefore g of 5. So g of 5 is, what is it? That is 11. Therefore 11. Therefore we got that g of f of 4 is 11. And the last element, that is g of f of 5. That is g of f of 5, that is equal to, what is g of 5? Sorry, f of 5 here? That is 5 itself. Therefore what is g of 5? That is 11. Okay, so therefore we got that g of f of 5 is equal to 11. This is how you will find g of f values. Example 16. Here you need to find g of f and f of g, where f is given from real to real And g is also given from real to real, and it is given by f of x is equal to cos x and g of x is equal to 3x square. And here you need to show that g of f is not equal to f of g. Given that f of x is equal to cos x and g of x is equal to 3x square, and we need to show that g of f is not equal to f of g. So to show this, first we shall go for g of f, then we'll check f of g, then we show that they are not same. Okay, g of f. So this also can be written as g of f of x. So this can also be written as g of f of x. And you know that first we shall solve this, that is nothing but first we shall consider the value of this, then we go for g. Okay, what is f of x here? Cos x. And now this cos x is in the place of x, right? So given that g of x is equal to 3x square, so wherever the x is there you need to substitute cos x. Now this looks as 3 cos x whole square. Did you get that? Okay. Now this can also be written as 3 cos square x. And this is what you got, that is g of f. Now we shall calculate f of g. f of g. This also can be written as f of g of x, and this is f of g of x. And what is g of x? Here we shall solve first g of x, then we shall go for f. So here what is g of x? G of x is nothing but 3x square, right? 3x square. Now what is f of x? Here what you have to do is wherever the x is there you need to substitute 3x square. Okay, that is cos 3x square. So here this is g, f of g you got. Now if you observe this and this, are they equal? No, right? So here you can write that g of f is not equal to f of g. But why they are not equal? 3 cos square x is equal to cos 3x square. Why they are not equal? Put some value for x. Let it be x is equal to 0. So if you look over here, they are not equal. Why? So if you look over here, this will be 3 cos square 0, and this will be cos 3 0 square is nothing but 0 itself, right? So here this will be 3 into cos square 0, and this is cos 0. 3 into 0 is 0, and here it is. And if you look over here is 3, this is nothing but cos square 0, cos 0 into cos 0, and this is cos 0 itself. And here 3, what is cos 0? We know that it is 1, right? 1 into 1, that is, here it is 1. And if you look over here, 3 into 1, and this is 1, and 3 is equal to 1. Is 3 is equal to 1? No. 3 cannot be equal to 1, and hence they are not equal. Example 18. So here we need to show that if f from a to b and g from b to c are 1, 1, then g of f from a to c is also 1, 1. So f and g, both the functions are 1, 1, then the combination of those two functions is also 1, 1 ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. Given that f from a to b and g from b to c are 1, 1, so if f is 1, 1, then we say that f of x1 is equal to f of x2, then x1 is equal to x2. So g is 1, 1 if g of x1 is equal to g of x2, then x1 is equal to x2. We need to prove that if g of f of x1 is equal to g of f of x2, then x1 is equal to x2. We need to prove this. So consider, we shall begin likewise, that is, suppose g of f of x1 is equal to g of f of x2. This can be written as g of f of x1 is equal to g of f of x2. And here, since f is 1, 1, we can say that we can replace f of x1 as x1 and f of x2 as x2. Why it is so? Look here. Since f is 1, 1, f of x1 can be written as x1 and f of x2 refers to x2. Therefore, here g of x1 is equal to g of x2. And here, since g is 1, 1, you can say that instead of g of x1, you can write it as x1. Instead of g of x2, you can write it as x2. Hence, if g of f of x1 is equal to g of f of x2, then x1 is equal to x2. Therefore, g of f is 1, 1.